Good afternoon, 7th hour. It's good to be with you, even if it is via video. All right, so here's what I need you to do. All right, so I've just got one quick thing for you. There's one more property of parallelograms that I want to go over with you that has to deal with the diagonals. Okay, this is in your packet, so if you want to pause the video for a second and pull out your packet, I believe it would be on page, I'm going to go somewhere around like 214 or 215, okay, and it would be number 17, or 7, excuse me. Okay. All right. So if you've got your packet in front of you, here we go. So this last property is that the diagonals of a parallelogram bisect each other. Okay. Remember what bisect means. Yeah, there you go. So bisect means that they divide each other in half, basically. Okay. So this does not mean that the diagonals altogether are congruent. It just means that the diagonals are going to divide each other in half. All right, so the first thing they want us to do is to rewrite this theorem in if-then form. The reason why they're doing that is because we're going to prove it here in a second, and they need us to have some guidance on, what is the if part, the given, and what's the then part, the prove. Okay, so I'm going to start out with if, it says the diagonals of a parallelogram, so obviously it's got to be a parallelogram, right? So I'm just going to go with if it is a parallelogram. Then, now we're going to have all this lovely information, right? The diagonals bisect each other. Perfect. All right, let's prove it. Okay, so they want us to draw a figure for the theorem, including the diagonals. So that means you're going to need to give your best artistic representation of a parallelogram. I'm going to cheat a little bit and use my tools that I have available to me because let's be fair here. My artisticness is not the best. There we go. Okay, so there's my parallelogram. Okay, make sure you draw in the diagonals. So that means you need to connect each of the opposite angles with a line like so. Perfect. Okay. All right, let's name our parallelogram. Might as well, let's go classic here. So parallelogram ABCD. Okay. And then we are going to need this intersection point in the middle, so let's call that X. That seems like a good place for an intersection. Okay. All right, the givens are going to be what the if part is here. Basically, what are we starting out knowing? And we're just going to start out knowing it's a parallelogram. Okay, so remember that little parallelogram symbol we learned yesterday? Let's use that instead of writing the whole thing. So parallelogram ABCD. Okay, we're going to try and prove that the diagonals, so in this case AC and BD, bisect each other. All right, you ready for this? Here we go, time to prove. Okay, all right, they say write a 2-column proof. Scratch that out. We're going to do a flowchart proof because this is another triangle congruence example, and so it's going to be a lot easier for us to do the flowchart proof. Okay, so the first thing we need is the triangles that we're going to prove that are congruent. Okay, and I'm going to guide you towards these triangles right here. Okay, triangle AXD and triangle BXC. Okay. As I look at these two triangles, think to yourself, what do I know is congruent between these? Ah, you're right, okay. I've got some vertical angles, right? Right here. Perfect, okay. What else do I have? Oh, you're right. This is a parallelogram, right? So let's use one of the properties we already know. Don't we know the opposite sides are congruent? Sure we do, okay. So I know those sides are congruent. Ah, very good. That's the last thing we're going to do. We're going to use these alternate interior angles right here. All right, so what congruence term is this going to be? Yep, angle, angle, side. And let's start off with that box right in the middle. Okay, so triangle AXD is congruent to triangle. And actually, let me make sure I get these matched up. So actually C would match with A, so CXB. And that would be by angle, angle, side. Okay. All right, so that means I need 3 boxes out in front of this for an angle, and a side. Okay. All right, so let's go ahead and work on this first pair of angles. Do you want to do the alternate interior angles? Yeah, that works for me. So let's call this angle DAX. That would be that angle right there. So angle DAX is congruent to angle, this one right here. So let's say BCX. Remember, we called those alternate interior angles. Okay. And by the way, if they're alternate interior angles, should they have a box in front of them? Yeah, absolutely. Okay, so let's make sure we have something like AD is parallel to BC and a given. Good. All right, our other pair of angles. So yeah, we can use these vertical angles here in the middle. So that would be angle AXD being congruent to angle CXB. Okay. The vertical angles theorem. Doing some heavy abbreviating here due to space. All right, so then last but not least, I need my sides. So that would be side AD and side BC, right? So side AD, give myself a little bit more room here. It's congruent to side BC. Okay, and we're gonna go ahead and just say property, so prop of, and then I'm gonna use the symbol for parallelogram, okay? Because that's what it is, the opposite sides are congruent if it is a parallelogram, so that's a property of parallelograms. Okay. Sweet, so have I proven my triangles are congruent? Yeah, absolutely, I have. Now, you might be thinking to yourself, wait, but we're trying to prove that AC bisects BD and vice versa. How in the world is this gonna help us? Well, let me show you something here. Okay, now that I've proven my triangles are congruent, do I now know that AX and XC are congruent? Absolutely, that's CP/CTC, right? Same with BX and XD, right? And if these halves are congruent, does that mean that X is a midpoint, that this is being bisected? You bet it does. Okay, so let's go ahead and have our next step be these segments by CP/CTC. So AX is congruent to CX, and then BX is congruent to DX. I know that's two things, but we're just going to put them all in the same box. That way we can save a little space. Okay, so that is the fabulous corresponding parts of congruent triangles. So therefore they are congruent. All right, so now that we know these halves are congruent, by definition of a bisector, that would mean that these are being divided in half, right? So I think we are at our proof. AC and BD bisect each other. And that is by definition of a bisector. Good. So you can see it's another nice, tidy little, triangle congruence proofs. I love showing you these things because it's like, hey, all that work that you did learning triangle congruence proofs, they are going to pay back multiple times to you as we go through the next units, because you're going to use these congruent triangle proofs over and over again to prove a variety of different things. And it's just kind of cool how that all comes together. Okay? All right, so here's the next thing I need you to locate, okay? So that's done with your packet. You can put your packet away. From your parallelograms practice, so this is what you took home last night, okay? You did all the problems except for 1, 5, and 10. So let me work 1, 5, and 10 with you, and then you can turn that in, and then the sub has some additional practice for you, okay? So first things first, let's do number 1 together. So this is applying that property that the diagonals of a parallelogram bisect each other, okay? So if the diagonals bisect each other, that means that these halves are the same, right? Because E is in the middle between all of them, okay? So for this one, I would solve for X and Y first, and I would do that by setting up two different equations, because I look at this and I see AE and EC are the two halves of this diagonal, so therefore I could set them equal to each other and figure out what Y is, okay? Same thing over here actually, okay? BE and ED should be the same length because they're the two halves of the diagonal. So 3y minus 13 should equal x plus 1. And then we solve. So over here, I would subtract your y's first. That's going to give you y equals 5. And then over here, let's subtract an x. So that gives us 2x minus 13 equals 1. Can add 13 to both sides. So that gives me 2x equals 14, which means x equals 7. Okay. All right, now that doesn't actually quite answer the question yet, though. They want the lengths of all our segments, but we could plug these in, right? Yeah, put 5 in for y, so that gives me 2 times 5, which is 10. Put 5 in down here. 5 plus 5 is 10. Hey, look at that. They ended up being the same. That's a good thing. That's what we were trying to do. Put 7 in for x, so 7 plus 1, that's 8 for DE. And then same up here, 3 times 7 is 21. 21 times, or minus 13 is also 8. Ta-da! Perfect. Okay, so that's an example of using the fact that the diagonals bisect each other. Okay, let's try another one. So take a look at question number 5 from your parallelograms practice. Okay, so if I were to tell you that ER right here is 19.6, okay, what would be the length of RG? Well, notice it's the other half of the diagonal, right? So it should be the same length. Very good. All there is to that one. Okay. All right, last but not least, let's do number 10 here, okay? So TR equals 42. So that's this entire diagonal equals 42, okay? ZR is 3x minus 6. Okay. All right, first things first. Are those two equal to each other? No, okay? ZR is clearly much shorter than TR, okay? But let's think relationships, okay? The diagonals bisect each other, which means these two halves are the same. So if this is 3x minus 6, I could say that this is basically 3x minus 6. Now these two together, that should equal TR, because that's the whole thing. So basically, let's combine these two together. So that would give me 6x minus 12 equals 42. All right, and then we can solve. So add 12 to both sides. 42 plus 12 is going to be 54. And divide both sides by 6, so x should equal 9. And I believe that's all they wanted. Okay. So there's a little bit of examples of how to use your diagonals there. Okay. All right. So at this point, if you did your homework last night, you should be good to turn in your parallelograms practice. So make sure that has your name on it and that it finds its way to my turn-in box. And so just to summarize, okay, because you're going to be doing some practicing with all of them here for a second. Okay. Properties of a parallelogram. Okay. The first thing you know is that consecutive angles are what? Very good. Supplementary. Okay, I'm going to do some abbreviating here. The opposite angles, those ones are congruent. So these are the ones across from each other. Okay. The opposite sides, very good, are also congruent. And then now you've just got this final one that we proved today, which is that the diagonals bisect each other. Okay, so take a couple seconds to look at this list, all right? These are your things that you know about parallelograms, okay? These were also listed at the top of your parallelograms practice. So, I mean, don't feel like you have to memorize them, but I feel like you're going to use them enough that you're going to become really familiar with them anyways. So it doesn't hurt to kind of start putting them in the memory. Okay, all right, so it's time to use these properties. Okay, so first thing you need to get from the substitute is an exit slip. Okay, it's 3 questions. It'll go pretty quick just to see how you're doing with your concept on parallelograms in general. And then the second thing you need to get from her or him is the additional parallelograms practice. All right, so it's a quick one. It's 10 questions. Yeah, 10 questions applying all of the properties. So it's got the angles on there, the diagonals, a little bit of everything. All right, work hard. Turn these 2 things in if you get them done in class. If you don't get the additional parallelograms practice done in class, then just do that for homework, please, and turn it in to me on Monday. All right, have a fabulous weekend, and I will see you then. Bye.